Good morning, my chemistry people, and welcome back to uh, chemistry. Post-test, we are starting a new unit. The new unit that we are starting is solutions. That's solutions as in a mixture of something. This is a vocab word that should be ringing distant bells in our memory from Unit 1, talking about different types of substances. A solution is a type of mixture, and we're going to do an entire unit just about solutions. Um, it is Solutions are very, very important because most of chemistry happens in a solution. In labs, when we mix chemicals with water, dissolve things in water, like we did in the copper penny lab, where we turned the penny into brass. Any lab where anything is mixed with water and a reaction happens in a beaker, that's happening in a solution. And water is such an important chemical, such an important substance in the world because of its ability to form solutions with so many different chemicals, so many different elements, providing a platform essentially for all of these different types of reactions to happen because water can dissolve so many different things. So solutions is what we are getting into today. It's a really fascinating unit. We're going to pare it down and go through it kind of quickly just because of the nature of online school, but we will be doing some fun labs. And this is the unit where you get to make rock candy. So that should be fun and something that you can do at home. So let's get into it. What we need, you of course are going to have your document, which you always turn in. So let's open this up. And this is a reworking of a lesson that I used last year, but we're going to do it a little differently. I still want you to do the IA. This is called a KWL chart, a what I know, what I want to know, and what I learned. So this is really, you're going to do these two boxes first, what you know. So like what is floating out of your brain from the past, from Unit 1? What do we know about solutions? Then what do we want to know? What can't you remember? What are you confused about? Um, why does this matter? Just what do you want to know? This will come back and do at the, ooh, excuse me. This will come back and do at the end of the lesson. So do you have any examples of solutions in the real world? I'm not going to give you any of these. You're going to come up with your own. So hit pause on the video and do boop, boop, and boop, and then unpause the video and continue. Okay. So I am going to put this in a new window so that we can see this separately. There we go. And then I'm going to open up the slides. So we have our definitions of solutions. A solution is a homogeneous mixture, meaning it is uniformly dispersed. So we talked about this in the very, very beginning lab, or way back at the end of the year, when you designed your own experiments of how to separate different mixtures of water and sand and salt and things like that. So when I say uniformly dispersed, that means that all of the particles of both substances are universally spread throughout. If I took an eyedropper and I went in and I took a little sample from right here, it would have the exact same percentage of water and our solute as it would if I took an eyedropper from over here. There's not two different phases. There is only one phase. When you take salt and you put it in water and you stir it up, the salt dissolves, it disappears. The salt is in the water. We can taste it, but we can't see it. The water and the salt have formed one homogeneous phase, so uniformly dispersed. I said the words solute and solvent a couple times, so we should probably define those. Solute in a solution is the substance that dissolves. So in the salt and water case, salt is the solute. It is the smaller part of what goes into the solution. The solvent is the other component. The solvent is the larger portion that does the dissolving. So salt goes into water and dissolves in salt, and dissolves into the water. So in that case, the water doing the dissolving, the bigger component is the solvent, and the salt is the solute. Example also with sugar, it's the same kind of thing. We have a lot more water than sugar. As a general rule, water will dissolve, whatever gets dissolved in water, there will be less dissolved than there is water particles. The bigger part of a solution is always going to be the solvent, and the smaller part is always going to be the solute. Another thing that I want to shake some brain cells and get us to remember some things is from the bonding unit. We talked about covalent and ionic bonds, and we did an experiment where we dissolved some things, we heated some things up, we mixed some things together. This idea of like dissolves like. Ionic compounds get dissolved by other ionic compounds. Covalent compounds get dissolved by other covalent things. And more specifically than covalent is polar. The water molecule has a positive and negative end. Bring up an image. The oxygen side is negative, and the hydrogen side of the molecule is positive. It's that positive and negative end that allows water to be such an efficient solvent, because it dissolves water, which has a positive ion, and water dissolves salt, which has a positive ion and a negative ion. Water also dissolves sugar, which is a polar covalent compound. So if we have charges, they will dissolve each other. Those are some things that we can look for and remind ourselves of as we go forward. As I was just saying, the difference in ionic charge or molecular polarity causes the solute to become dissolved. So when we put the salt with the positive sodium ion and the negative chlorine ion into water, the positive and negative ends of the water molecules pull those atoms apart and dissolve them into a liquid solution. So the examples that we've used so far have been liquids, but I want to remind you that, well, usually a solution is a liquid. Not all solutions are liquids. It is possible to have a solid solution, and an example of that will be coming down the pipe, but we'll get to that. So some memory tools. It can be difficult to remember solute versus solvent, like which is which. So solute is a shorter word, only 6 letters, it's the smaller part. Solvent, longer word, it's the larger part. So that's a quick and easy one. A little more convoluted one, and I like my cheesy memory tools, so I'm going to give you this one. A thief broke into a building and filled a bag with loot. Then the police came. The thief hid the loot in a vent so he couldn't get caught. I don't know if you guys have ever seen that movie with Eddie Murphy where he hides a diamond in a vent and then comes back like 20 years after he gets out of prison, and it's a police station. Great movie. Anyway, he hides the loot in the vent. The solute goes in the solvent. The loot goes into the vent. The solute into the solvent. Okay? So I like it. It's corny. It's good. Hang on to that. So after you have your notes done, put up here, you're going to come to here, a gallery walk. So this table has lines 1 through 10. If we go back to our assignment, here we go, gallery walk. The 10 images that you're going to be analyzing are in here. So you can scroll through and you'll be given all of these examples that you can fill out. Oh, I just noticed they're out of order. Don't worry, I will fix that before I post it. Okay, so you're going to put all these things in. So you go 1 here. What's the salt? Is it a solution, first of all? Yes. Salt dissolved in water, that is a solution. There is only one phase. So salt is our solute, and water is our solvent. Rationale, why do I think this? This is a solution because it is a homogeneous mixture of two substances. And I can even strengthen this by saying the salt and water form one phase of matter. They form one liquid solution. So let's go to 8. Okay, they're out again, they're out of order. I'll fix this. If we go to 8, here's water. Is this a solution? Well, no. And there's a couple of reasons why. No, it's not a solution. We have ice floating in a water glass. Right off the bat, we have two different phases. So it can't be a solution because we have a solid and a liquid. It could be a mixture. A solid and a liquid can make a mixture because there's two different phases there, but it can't be a solution. Another thing, what is the chemical difference between ice and water? The structure of the molecules, one's solid, one's liquid, but they're both H2O. So in this case, there is no solute. The solvent would be water. So my rationale for why can't this be a solution? There is only one substance, H2O. Another reason why this is not a solution is that there are two phases of matter, solid and liquid. So you're going to proceed through this document and you're going to do this whole table using this gallery walk. When you're done, that's when you go back up to the IA, finish this last box in the IA, and then back down to do your exit ticket. Keep in mind that you can also edit this document. You can leave comments. I'm going to set the setting so that you can leave comments. You won't be able to edit the document, but you will be able to highlight the picture and then leave a comment for me, so I can answer you. You can also leave comments privately in the assignment or on the assignment page itself. If you leave comments in here on the document, it is more likely that another student might see and respond to you. A little collaborative learning is never a bad thing. So the last thing that I want to point out is this column right here, peer review. I'm not requiring you to do this, but I will give you bonus points if you do this. So what you're going to have to do this is you're going to have to click share, and you are going to have to send this to a classmate of yours. Once you share this to a classmate, they can open it up, leave comments in here for you. And I think if someone is going to peer review your work, you should peer review somebody else's work. So find a classmate, swap, do a peer review, get some bonus points. If you share the document and your classmates leave comments in here, it won't change anything. You can still click turn in, and I'll be able to view it, and I'll be able to see the comments in there as well. All right, guys, have fun with this. Enjoy this introduction to solutions, refresher of some stuff that we've talked about already, some clarification, and refreshing our brains for the next unit. All right, guys, have fun and good luck.